Alright, so let's do the last section here. So we're going to do solving the equations, and we are going to keep the angles we are looking for between 0 and 2 pi closed and at 0 but open at 2 pi, right? So that would not be included because it's already part of the 0. And so tangent of 2 theta equals 0. So we have to ask ourselves the tangent is 0 when? Well, tangent is 0 when the sine is 0, right? Because what's your tangent? Tangent of an angle, whatever the angle is, let's call it beta so we don't have the same thing here. A tangent of an angle is going to be equal to the sine of that angle over the cosine of that angle. Well, which one of those two has to be 0 for the tangent itself to be equal to 0? Well, it can't be cosine, because if cosine is 0, this whole thing is undefined, right? Because we cannot have a denominator of 0. So it has to be the sine. So tangent beta is going to be 0 when the sine is equal to 0. And so we're going to say, okay, tangent is going to be 0 when the sine of 2 theta is going to be 0. And so sine of theta, that happens when the sine of 2 theta equals 0. And so now I have to ask myself, I am between 0 and 2 pi on the unit circle, and where is the sine going to be equal to 0 on that interval? Well, right there, and then right there, right? So at 0 and at pi, and we don't go to 2 pi because that's an open interval. So this is going to be 0 when 2 theta is equal to either 0 or when 2 theta is equal to pi, right here, right? And then we just solve. So divide by 2 here, therefore theta is going to be equal to 0. And divide by 2 here, therefore theta is going to be equal to pi over 2. Okay, so we have two solutions. Hold on. And so now I have to worry if I need more. Am I missing something? So because I have, this is more than just an angle, right? So I need to think. Maybe I should have done that before. I write everything here, but I have to say, okay, 2 theta is equal to 0, and then what is, I'm with a tangent here, so what's the period of a tangent? The period of a tangent is pi, right? And so I need to say, okay, 2 theta is going to be 0 plus pi n, and then I'm going to use that, and I'm going to say 2 theta is going to be pi plus pi n. And I just need to check, right? I need to check if I have more possibilities within that unit circle, because this is more than just a theta. It's a 2 theta. So when I'm looking at that, if n is 0, then that goes to 0, and that will be 0. So this is what I had here. Let's divide by 2 on both sides first. So 0 divided by 2 is 0. Pi divided by 2 is pi over 2. Okay, so now let's do it again. When I plug in a 0, that goes away, so theta is equal to 0, which is what I already have here. If n is 1, then that will be pi over 2, and so I will have 0 plus pi over 2, which is pi over 2. And that definitely is within my circle there, so I would have to add there. Theta is 0, let's open that. And say, or pi over 2. But I already had my pi over 2 here, didn't I? So that was good. And then plug in a 2 here, what would happen? 2 over 2, those will cancel, so I would just be left with a pi here, right? And so I would also have a pi. And then plug in a 3, that would be 3 pi over 2. And so that's still within one unit circle, right? So I'm going to have 3 pi over 2. And if I plug in a 4, 4 divided by 2 is 2, so I'll have 2 pi, and then I'm outside of my domain here, right? Outside of my reach right there. So really I would have all of those solutions that I need to involve. Okay, sine theta plus sine 2 theta is equal to 0. So let's see what we can do on that one. I need to rewrite that so I have a single angle here. I cannot have a double angle, right? So I'm going to say, okay, sine theta, that's this one, plus rewrite that, so that's 2 sine theta cosine theta equals 0. So that was just rewriting that double angle so that we have single angles right there, right? And now I look, so I have an equal 0, that's kind of good already, but then I would want to have this side factored. So I'm looking, what do I have here and there that's common? Well, both of those terms have a sign, so I'm going to factor out the sine, open a parenthesis. If I divide this sine theta by sine theta, I'm left with just a 1. And then I divide this term by sine theta, I'm left with 2 cosine theta equals 0. And now this is the zero product property. When you multiply two things and you get a 0, then you know one of the factors has to be 0. So set that equal to 0. And when is your sine equal to 0? For what angles? And my sine is equal to 0 at 0 and at pi. Remember, we don't want 2 pi, right? Because it's not part of our domain that we're looking at. And then you need this factor, set it equal to 0. So 1 plus 2 cosine theta equals 0. Subtract 1 and divide by 2 will give you a cosine theta equal to, subtract the 1, divide by 2. And when is cosine theta equal to negative 1/2, and your cosine is negative in quadrant 2 and 4, in 2 and 3, right? Because that's where the x's are negative. And so you want it a 1/2 value, so that will be up here and down there. So that will be 4 theta is equal to 2 pi over 3 and 4 pi over 3. Okay? 21. Okay, so I see 3 terms. I see one is quadratic, right? One is just the same trig function, but not quadratic, and then just a constant. My first thought right away is factoring, right there, factoring. Okay, so what can I multiply here and here to give me that 2 sine squared? Well, 2 sine x, oh sorry, that's not x, that's alpha, and then a sine alpha, right? Multiply those two together, you will get by your 2 sine squared. And then what can you multiply here and there to give you a 1? Well, we don't have any options, right? That's a 1 and a 1. However, now we need a negative 3 in the middle. So when you multiply the outers, 2 times 1, you will get a 2 sine theta, and then 1 times sine theta, sine alpha will be 1 sine alpha. And when you add those together, you need a negative 3, the middle term up here, right? Sine alpha. Well, the only way I can get a negative out of those two is if they're both negative, so minus and minus. That being done, let's put that on the side. That being done, now we have a product that gives us a 0, so we know by the zero product property that 2 sine alpha minus 1 equals 0. Add 1 to both sides, divide by 2, so sine alpha is equal to 1/2. And where is my sine? Sine are your y values, so those are positive in quadrant 1 and 2. And the sine is 1/2 here and there, so at pi over 6 and 5 pi over 6. So alpha equals pi over 6 and 5 pi over 6. And then for this one, we have sine alpha minus 1 equals 0. And so we're adding 1 to both sides. And where is my sine equal to a positive 1? Well, that will be up here, right, at pi over 2. So alpha is also going to be equal to pi over 2. I'd like to go back here for a second on 19. We also know that the period of tangent is really pi, right? The period of the tangent, of the parent function for the tangent. But we have to worry about tangent could have some undefined values, right? So if I plug in a 0, I'm going to get 2 times 0 is 0. We're good, right? Tangent of 0 is defined. If I plug in pi over 2 is normally not defined for the parent function of the tangent. But if you substitute theta with pi over 2, you get 2 times pi over 2, which is pi, and the tangent is defined at pi. And so if I put in a pi here, I get 2 pi, and so we're good there too. And if I put a 3 pi over 2, we're going to get 3 pi over 2 times 2, which is 3 pi, which we're good there too. Okay? So I just thought I should make sure we clarify that. All right, let's keep going. We're going 22. That underneath. 22, yes, can you see it? Okay. So for 22, we have a whole bunch of stuff, right? We have cosine, we have squared and squared, quadratic terms, and then we have single linear terms, right? So let's see what we can do. When I'm looking at that, I say, oh, that cosine squared minus sine squared, those together maybe can give me something. And then minus, and then this one here, I also recognize as one of my formulas. So this right there, I hope you recognize this as your double angle for the cosine. So that just becomes a cosine of 2 beta. Now be careful, not a cosine square, right? Because the cosine 2 beta is actually cosine squared minus sine squared, right? So this one is a single, a linear term. And then you need to recognize that as being your sine of 2 beta is equal to 0. So that's just a matter of recognizing your formulas right there. And then once I have that, I need to ask myself, well, let's actually, I'm not sure why this became a minus. That should be a plus. I hope you caught that earlier than I did. I just caught it now. Probably heard you scream at me through the screen. Okay, so this is a plus. I'm going to actually go ahead and move that across the equal sign. So I'm going to have a cosine 2 beta equals, and then subtract that from both sides, becomes negative sine 2 beta. And the only reason I wanted to do that is because now I have a cosine of something that's equal to the opposite of the sine of that same angle, right? A cosine of an angle equal to the opposite of the sine of that angle. So think about your unit circle and ask yourself, where is that happening? Where are the sines and the cosines the same except for the sine issue, right? Well, the only place where cosine and sine are equal to each other, the x and the y ordered pair, will be at the 45s, right? Where we have the square root of 2 over 2 and the square root of 2 over 2. But we want one to be positive, one to be negative. So where are they opposite of each other? So that will be in quadrant 2 and in quadrant 4, right? So we need that angle and we need that angle. That's where that would happen. So 2 beta would have to be equal to 3 pi over 4, and 2 beta would be equal to 7 pi over 4 for that one, right? Okay, so then I need also to worry about the period of sine and cosine is 2 pi, right? So period, I'm going to do that right away as opposed to earlier. The period of sine and cosine is 2 pi. So when I'm going to do that here, I'm going to say it could be this plus any 2 pi n that will still be within my unit circle, within one revolution, right? Plus 2 pi n, okay? Divide by 2 everywhere. So beta is equal to, divide by 2, that gives you 3 pi over 8, and divide that by 2, just cancel that 2, so plus pi n. And here same thing, so we're going to have beta is equal to 7 pi over 8 plus, and divide that by 2 will be pi n. Alright, so now we have to ask ourselves, when n is 0, remember n can only be an integer, right? like 0, 1, 2, 3. When n is 0, well, 0 pi is 0, so we have 3 pi over 8. So let's put all our angles possible here. Beta is going to be equal to, so we will have that 3 pi over 8. When n is 1, I'll have that plus pi, right? So 3 pi, I'm going to do that on my whiteboard here. So we'll have 3 pi over 8 plus 1 pi, right? We said n is 1. Well, we need a common denominator, so multiply by 8, top and bottom. And so now I have 3 pi plus 8 pi, that'll be 11 pi over 8. So this here would still be within my unit circle, right? So I'm going to put that down also as a solution. So 11 pi over 8. And then if I put a 2 here, then that would be 2 pi. So now I'm adding, change that. So now I'm adding 2 pi, right, if n is 2. And I need a common denominator, so multiply by 8. So that would be 16, so that would be 3 pi plus 16 pi over 8. And that would be 19 pi over 8, and that will be past 2 pi, right? Because 2 times 8 is 16, so anything above 16 will be above 2 pi, so that will be past what we have, so we don't want that. So now we go to the other side here, and we are going to do the same thinking. When n is 0, that goes to 0, then we left with 7 pi over 8, so that's part of our angles, so we're going to add 7 pi over 8. When n is 1, then we'll have 7 pi over 8 plus pi. So again, let's go here, and let's do 7 pi over 8 plus pi. Well, we need to multiply top and bottom by 8 to have a common denominator. And then 7 pi plus 8 pi, sorry, is 15 pi over 8. Well, 16 pi over 8 will be our 2 pi, right? That's our limit. So we're still below the limit, but we already know that the next one will be above, so we can stop, right? But this one is still there. So 15 pi over 8 is also one of my angles. And so those will be all our solutions. Again, this is a video, right? So you can rewind, you can stop me, you can listen to it again and make sure you understand. The big deal is that we need all the possible angles within one revolution of the circle, because that was our restrictions, right? We were going between 0 and 2 pi. And because we're dealing with not single angles, we have double angles, or when we have half angles, I think was the example earlier, that's when we have to make sure we check that, right? So we're looking at the period of the trig functions we're working with. Sine and cosine are both period of 2 pi. And so you're going to take whatever angle you come up with when you do your unit circle, and you look at all the options if you do that plus 2 pi n, and then just pick your values for n, right? All right, 23. 23, well, I'm looking at that and I see a difference of sums. So let's see if we can do that. So that negative 3, first of all, is in the front, right? So I'm going to leave it there. So negative 3. And then do your difference of sums. So we have the cosine of the first angle times the cosine of the second angle plus, because we have a minus here, so in cosine becomes plus, sine of that first angle times sine of that second angle. And all of that has to be equal to tangent. How about we go ahead and change that tangent already? Because I'm looking here and I only see sines and cosines. So how about changing tangent to a sine theta over a cosine theta also, so that everything now is in sine and cosine terms. Alright, so what do I know? Well, I have a few things I know. I do know cosine pi over 2, because that's a definite angle. I know can find that on my unit circle, and I can find that on my unit circle. So we have negative 3. Notice how this cosine of pi over 2 is 0, and it's multiplied by cosine theta. So that whole thing goes to 0, right? Okay, so that would be that times 0 plus, and then that negative 3 has to be distributed, right? So actually, instead of doing plus, then I'm going to say minus. Again, I'm multiplying this with that first term, and then negative 3 with that second one, right? So minus 3 sine pi over 2. Well, we know that's just going to be a 1. And then sine theta has to be equal to sine theta, slip of the pen right there, cosine theta. Alright, this here just goes to 0, so we can ignore it. That's a negative 3 times 1 is negative 3, so I have a negative 3 sine theta. And I don't want that fraction there, so I'm going to go ahead and multiply both sides by a cosine, okay? So multiply this by a cosine will give me cosine theta. And multiplying here by a cosine will just cancel that cosine. I hope you can see that. What I'm doing is I'm multiplying that side by a cosine and that side by a cosine, right? So those are cancelling, and that will just be negative 3 sine cosine, right? Right there. Okay, at this point, I want that set equal to 0, so I am going to, how about add that to the other side? So I'm going to get a 0 equals, so I had my sine, that sine, and then when I take this and I add it to both sides, it will become a plus 3 sine theta minus cosine, sorry, that's not a minus, that's multiplication, times cosine theta, okay? And I have two terms, and both of them have a factor of a sine, so I can factor out a sine. So I'm going to come here, and I'm going to say, okay, 0 equals, I'm going to factor out a sine. If I divide sine by sine, I'm left with a 1, and factor out a sine here, I'm left with 3 and the cosine. So plus 3 cosine theta. Why did I want to do that? Because now I have a product, and by the product zero product property, I know that if I multiply two things and I get a 0, I can say, okay, then one factor set equal to 0, or the other one set equal to 0. And we know that sine is 0 when theta is equal to 0 and pi. And cosine, here I'm going to subtract 1 and divide by 3. So I have a cosine theta, subtract 1 and divide by 3. And I need to ask myself, where is the cosine theta equal to negative 1/3? Well, we have no idea because this is not in our unit circle. So the only thing we can say here, since we need a theta equal, the only thing we can say here is theta equals the cosine inverse of whatever that will be, right? And if you put this in your calculator, you're going to get a decimal approximation, but I like the exact answer, so we're going to leave it like that. But technically, your calculator will give you an about be about 1.91063 according to my calculator, okay? Oh, and the cosine actually is negative in quadrant 2 and 3, so therefore I have another option here. Whoa, okay. Or, so I'm going to take that. Oh, so that will be about 4.37255. Well, it's probably going to be just simpler to just leave that right there, so that we don't have to worry about those two different answers. So we have those two, and here we have 2 included because this will be in quadrant 2 and 3 again. Okay, I think I'm going to stop right there.